Hello, fellow problem solvers. So today we're going to be doing a problem from the 2008 IMO, problem number 3. I suggest you try this difficult problem out for a minimum of 30 minutes, ideally 2 hours, but not more than 3.5 hours. If on the other hand you'd like to go along with us, I suggest you give it a go. Put your first ideas out on paper. Think about what is it that the problem is really asking you to prove for the next 10 minutes. And now, without further ado, let's begin. So we must show that there's infinitely many n such that if p divides n squared plus 1, then p is greater than this. So, that it has actually a prime divisor that's greater than this. That's what we need to prove. And think about, what does this mean? If p divides this, that means n squared is congruent to negative 1 modulo p, right? And you want to find infinitely many such n for a prime p that's big enough. So the converse is also looking at it the other way. Is we want this to have a solution for that prime. It needs to have a solution. So that's the first thing. And then not only does it have a solution, it actually has two, because the quadratic residues come in pairs. So it has two solutions, and we need to take the smaller one, and then we can estimate it with this. Now, first things first. This means n to the power of 4 is 1 modulo p, and now that n to the p minus 1 is also 1 modulo p, then n to the power of the GCD of 4 and p minus 1 is also 1 modulo p, and given that this can either be 1, 2, or 4, it can't be 2 or 1, because then n squared wouldn't be 1 modulo p, so it has to be 4, which means 4 needs to divide p minus 1. And the converse is actually true. If 4 divides p minus 1, then p has quadratic residues that are congruent to minus 1 modulo p, and it has two of them. Now again, let's take the smaller one, and then n is less than or equal to p minus 1 over 2. And now let's look at our estimate, mind you. Our estimate of 2n plus the square root of 2n is going to be less than or equal to p minus 1 plus the square root of p minus 1. Okay, this is not great. This is a bit too big. We need this to be less than p. But now we need to sort of maybe estimate. It's not going to be minus 1 over 2, but we need to find something else. And here I invite you to pause for another 5 minutes and see what is the next step you would take. And here's my next step. I would say, okay, let's actually make this formal. This is p minus 1 over 2 minus L. And now, what does this condition turn into? Well, I have p minus 1 over 2 minus L squared is negative 1 modulo p. Multiply everything through by 4 and square them. You'll get rid of p, and you'll be left with 4L squared plus, 4L, I believe, plus 1 is congruent to minus 4 modulo p. Because the p's are congruent to 0, and p minus 1 is congruent to minus 1. So when you have minus L times p minus 1, that will be congruent to L. So that's how you'll get this when you multiply by 4. And now, with this in mind, this means 2L plus 1 squared plus 4 is divisible by p. Okay, and this gives us constraints, like L won't be equal to 1. We have L now in terms of p, this is equal to p times some r. And now's the time when we need to estimate, what does r have to be. So we have this is equal to pr minus 4, square root of that. So L is going to be equal to the square root of pr minus 4 minus 1 over 2. And then we have p minus 1 over 2, n is this minus L. So it's going to be p minus 1 over 2 minus the square root of pr minus 4 plus 1. Those cancel out, and you get n is equal to p minus the square root of pr minus 4 over 2. And then what does that give us? So that gives us that 2n plus the square root of 2n is going to be equal to 1 is going to be p minus the square root of pr minus 4 plus the square root of p minus the square root of pr minus 4. And now this thing right here we need to prove is less than p. In other words, what we need to show is that pr minus 4, the square root of that, will be greater than the square root of p minus the square root of pr minus 4. Now, this almost seems definitely true, right? I mean, actually here is where I would invite you to pause and check if we've made any mistakes here. So pause for the next 5 to 10 minutes and see if we made any mistakes and push the problem further. Here's the next step. So all is actually good. We just need pr minus 4 to be greater than p minus the square root of pr minus 4, which is the same as this being true, because I mean, our 2l plus 1 squared thing is not going to be like this is negative 4 modulo p. L isn't going to be 0. So for p large enough, and now we need this to be true, but for that it's enough that p minus 4 is greater than 16, i.e. p is greater than 20, and we're done really. This is how we can solve our problem. And now we just need a write-up, and I invite you to take 5 minutes and write this problem up. Here's the write-up. So we say take p a prime with p greater than 20 and p congruent to 1 modulo 4. Then there exists x and y such that x squared and y squared is negative 1 modulo p. This part, I mean, this is somewhat well known in the quadratic reciprocity. I can make a video about it if you want, this sort of thing in general. And then we say let x be less than y. I'll take the smaller one. Let's equal this, set it to this. We get our estimate for L is greater than this, which means x is less than or equal to this. Now for n equals x, we have p divides n squared plus 1. And this whole thing is less than this, which is less than p if and only if p is greater than 20. And now with that, this shows that given there's infinitely many such p, and n has to be at least the square root of p minus 1, that means we have an infinitely many n. I mean, this is just important so that the same n doesn't appear for different primes. And the same set of n, finite set of n, does not appear for an infinite set of primes. That's why this part is important, and such that this is true, and now we're done. This solves our problem. And it's nice, it's quadratic reciprocity at the IMO shows you, like, it's about technique here, really. There's a little bit of thinking, like instead of looking for n, look for p, but that's that. And as always, thanks for problem solving.